Hey, what's up? Alex over here. One of my goals for 2025 is just to be a better software engineer. Um, and I have goals both for work as well as outside work. And one of the things that I have set as a goal for me outside work was to be a better system level programmer, have a better understanding of computer architecture, better understanding of assembly language, and better understanding of system level programming languages like C, um, Zig, and C++. So as part of my goal, I bought this book called C, the C Programming Language, written by Brian Kernighan and Dennis M. Ritchie, which are very renowned software engineers and computer scientists that built the Unix um, operating system that initially run on or ran on the PDP. I think it was PDP 11 or the PDP. There was a PDP prior to this that was written in B by Ken Thompson, but as we know, it was rewritten to run on the PDP 11 with the C programming language. So one of my goals is to just be a better C programmer, and for that, I wanted to take some time to understand code bases written in C and C++. And one of the victims that I have in mind is Redis. So my goal for today is to um, go to Redis, understand um, Redis, GitHub. Yeah, understand the code base. But before that, I want to understand just how we can build Redis locally. I can run tests for it before actually looking at the code base. So this is the Redis GitHub page. Explains what Redis is. Well, it's simply a data store for most. A lot of people use it for caching, for data stores, or as a data store, and a whole bunch of other interesting use cases. So yeah, my goal is to build Redis locally, and then start digging into the code base just to understand how the project works. So yeah, let's start with building. So it's good to read the documentation. So let's do that. So building Redis. Redis can be compiled and used on Linux, OS X, OpenBSD, NetBSD, and FreeBSD. We support big Indian and little Indian architectures such as and both 32-bit and 64-bit systems. Okay, cool. It may compile on Solaris-derived systems, for instance, Smart OS, but our support for this platform is best effort, and Redis is not guaranteed to work as well as in Linux, OS X, and BSD. So essentially, here they're saying that these are the three systems that you are more likely to have success building, compiling Redis. And then we go on to see how we can compile using Make. Make with transport layer security using OpenSSL. This seems to be the lib that we use on Ubuntu and Debian to get SSL support working here, but that's not what we plan to do. To build with systemd support, you need systemd development libraries such as libsystemd dev on Debian/Ubuntu, or systemd dlevel or devil on CentOS, and run this. That's not what we want to do. Don't think we're going to go that route. To append a suffix to Redis program names, use. Okay, cool. You can build a 32-bit Redis binary using Make 32-bit. After building Redis, it is a good idea to test it using make test. Okay. 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 So if we get any issues building stuff, then we can just run make this clean. Okay. Okay, this will clean all the dependencies. What's that? Okay. Cool. Allocator. Okay, so it looks like you could specify different allocators. So you can use the standard libc allocator. So this is most likely an environment variable that we're setting before running make, or just after it, as we run it. And you read that environment variable, check that we will read this, and then it will load the correct the correct allocator for you. And then you can also use this allocator here, gemalloc. Interesting. What's gemalloc? Gemalloc is a general purpose malloc implementation that emphasizes fragmentation avoidance and scalable concurrency support. Okay. So fragmentation avoidance and scalable concurrency support is what gemalloc provides. Okay, here we'll talk about the monotonic clock. I wonder why this is necessary. Sometimes it's necessary for certain types of work, especially when you're running some kind of hashing algorithm. Running Redis, so you can run it with that, and you can play around with that, and you can install it into your system. Okay, cool. So ready enough for the documentation. We have understanding of how to compile this. According to the documentation, it should be as simple as running make. Let's put this documentation to the limit, or rather to the test. So let's go to Ghosty. I'm in the project folder where I usually add all my C projects. And you can see if I type ls, I can see I have core utils here. But now I want to clone this project. So I'll get the SSH URL. And do I even have Git installed here? No, I don't have Git installed. So let me install Git quickly. This is a fresh Ubuntu installation. That's running via OrbStack. I didn't want to compile it using Mac OS. Okay. So that's installed. So let's clone this project. Oh, please type yes. Yes. Okay, this is going to take maybe 40 seconds or so to download the Redis code base into our file system. I can wait. Can you wait? Do you have the patience? I certainly do. Okay, well, that's doing its magic. Is there anything else that's interesting here that we might want to get into? Okay, code contributions. Okay. So they do they do allow um, contributions, which is good. I mean, that's what open source is all about. Let's see how far that's done. Okay, that's good. Do we have make? No, so we also have to install make. Done. Hopefully it's just as simple as running make. Okay, I actually have to go into the Redis folder and then run make. All right, what happened there? CC not found. Okay, that makes sense. We need the GNU compiler. So you can install the GNU compiler this way. Yes, I want to continue. 134 megabytes. It's gonna take about a couple of seconds to download. Cool, so I'm packing everything. Okay, cool. GCC seems to be installed. Now we can run make. All right. So compilation terminated. Error is 1. Error 2. Okay, so we need the... Okay. This is that general purpose memory allocator that we learned about earlier. It looks like it's by default compiling with jmalloc. We don't want that to be the case. The documentation did mention that we can use the libc variant of the allocator, which is this one. So let's try and run that. Make malloc equal libc. Okay. Okay. We can actually see some of the optimizations that's happening. It's being applied. Okay. We can see the object files that are being generated. So at this stage, we get this error. No such file or directory. It's in this folder called deps. So if we do ls, is there deps? Okay, there's a deps folder over here. Let's go into that quickly. cd deps. I don't have nano available to me. Oh, that sucks. Fine. So it looks like we have a couple of folders. These seem to be dependencies that need to be installed. So let me do this. Make fast float. Okay, it attempted to do that. Cd it into the folder, and then it ran make live fast float. Enter the directory. Then it tried to run g++ for these optimizations for the C++ code, for this C++ file. And then because we don't have G++, okay, we don't have G++ installed, right? So that means we have to install it. Yes. So let's run fast load, which is a dependency that Redis needs. Okay, so it created the file that it expects. I'm guessing we can now leave, we can cd out of this folder, or we can type malloc equal libc, and this should ideally compile successfully. So we can actually see like some of the things that we have: Redis server, Redis Sentinel. Here the object file that GCC output. So we have Redis CLI, Redis assert, CLI common, CLI commands, Redis benchmark. Okay, cool. It's a good idea to run make test. Okay. Well, let's run the test. Oh, another error. Okay, cool. Looks like I need another application. PKG. No, looks like it's TCL. You need TCL 8.5 or newer in order to run Redis test. Okay. TCL, tender care loving. Tender loving care. Tender love. I think it's a tender loving care. Tender love. Tender love is actually one of a legendary, I would say, contributor, open source contributor. I think he contributed to a couple of projects. One of them is Ruby. And I think it does use C a lot to make Ruby faster, if I remember correctly. Yeah. Cool. So that seems to have worked. Run make test. Okay. Interesting. Cool. Got the test running. Now let's get into Fleet, which is the code editor that I'm using. And we should, yeah, we have Redis here. Let's look at the project structure. So source, whole bunch of files. So like all the headers and the actual source code, header files, source files, they're all in the root of the source. Yeah, they're not organized in any fancy way. It's a fairly flat structure here, so it's fairly easy to follow. We have commands that contain JSON files. So are these like this? So I'm assuming these objects are related to specific commands that the Redis CLI supports. For example, who am I? So given, maybe it reads these objects, these files over here, and from that it essentially generates all the descriptions, all the information, specifies the command flags that it supports in the CLI. Well, that's my assumption. What would be the entry point to, 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 what would to the actual application. Let's search for main. So we have one here for test and one here for server. So that looks like the entry point. Okay. Here we define a structure, define an integer, we declare a char or car, whatever. Monotonic initializer required for dict tests that are relying on monotime during dictionary rehashing. Okay. If we have more, or if the argc is more equal to 3 and test is equal to whatever is in here, or it's not equal to whatever is in here, then okay, so we're not, if we're not running in test in the test environment or test mode, then we run whatever is in this the body of this condition. Have this loop. We set arg based on the list that was passed into here, which is essentially the list of arguments that are passed when you run the server, I guess. And that's why it needs to check that it's not running in test. And then you can, so I guess a few of the arguments that you can pass is accurate, is large, valgrind. I'm guessing isn't valgrind used for like debugging or finding errors in C++ code bases? Yeah, okay, so that's it. Debugging, profiling, automatic detect memory management, threading bugs. Okay, yeah, I remember this from a long time ago when I was learning C. I think when I was a teenager. Yeah, so the tests ran successfully. That's good. So we just have a whole bunch of conditions. So basically, if this is found, if this is not found, then we set flags. Right? If the thing that we're looking for does not match what's in arg, then we set these flags. What's the syntax? I'm not sure if we set or yeah, this is kind of confusing me, this one. Yeah, because it's not the standard, because font ligature, so it's not standard. Yeah, not standard ligature, so it's kind of hard to understand what's happening here because I haven't seen this before. Cool. So if whatever is here is in the second index of argv is not equal to all, then we essentially get the size of, okay, so we're gonna get the size of Redis tests. So this essentially allows us to, this syntax array allows us to get the size of a struct, right? If I get the size of a struct, this is what you will use, size of this and divide by size of and the struct, or you can also do that to arrays, I think. Yeah. Where is this defined anyways? This Redis test thing. If I search for this, actually only, okay, first mention of this. Okay, so it's Redis test. Okay. So this is a struct. These are the properties. Pointed to a name. Proc pointed to a Redis test procedure, I guess, and int describing if the test failed or not. And I'm guessing these are the different type of tests that are run. And then we have this function gets appointed to a name. Okay. Yeah, pointed to a name. It gets the number of tests, loops through the number of tests. If the name is not equal to this, then we return the procedure based on this index. Then we jump out of the loop and return null. Okay, cool. Okay, I wonder if this is what's responsible for running those tests initially. I wonder. And then here we actually get into the server stuff. To achieve entropy in case of containers, their time and get PID can be the same, but the value of TVUSEC is fast enough to make the difference. So get PID is a function, is a function to get the process ID of the current process, and time kind of self-explanatory. So we get the time of day, generate a random string, I guess, based on the time and the process ID. Here we do something similar. And then here we generate the random 64-bit. Generate random 64. What does this do? Okay, so it initializes what's MTT with the seed. Okay. It equals this. I'm not sure what this does. Okay. We store the umask. So this is essentially the permissions that for the server 777. Yeah. We declare this variable, assign and then signed 8-bit integer. So it's essentially get random bytes. All right. Okay, so here we see zmalloc. So this looks like an implementation, another implementation of malloc. So far we've seen there's the one that we saw here, jmalloc, and then there's zmalloc, which is part of the source code. Let's quickly search for that. C malloc. There we go. Get the header file. So we have a couple of macros. Okay. Okay, so it's essentially a zmalloc is an implementation of malloc or wrapper over malloc, and it just adds a couple of niceties. Usable, reusable, used memory. Okay, so you can, with this implementation, it looks like you can query the amount of memory that has been allocated by the application. So this can be useful in situations where you run a specific command where you know that it's going to be memory intensive. So you want to, before you run it, you want to have a condition. Okay, do we have enough memory? How much memory do we have now? Okay, we have enough memory. Now we can actually run this. So I guess for their particular use case, seems to be useful to them. All right. If you use zmalloc usable size to obtain additional available memory size and manipulate it, we need to call extend to usable afterwards to ensure the compiler recognizes this extra memory. However, if we use the pointer obtained from z usable family function, there's no need for this step. Okay, so yeah, it's definitely the case. Okay, definitely the case that they use this to query that. It's essentially a wrapper over malloc that allows you, that gives you a couple of niceties so that you can query the usable memory before you do certain operations. Okay, cool. So I guess for today, this is going to be it. I'm going to take more time tomorrow to actually look further into this. But it was nice actually going through the code base so far and making sure that we could compile. We read the documentation. We got an understanding of we got into the main entry point of the application, and we learning a bit more about how this thing works. So yeah, very interesting. Yeah, so that's it for today. Let's see what happens in the next episode. Cheers. Bye.